and TAS has quite a powerful API. We've got lots of integrations with different packages. And this is something that quite a lot of our customers, especially our bigger customers, really value. For example, the ability to get information in and out of Excel via macros. They find that very useful. And the optimization that we have in the software as well. Anything that you can do with the UI, you can optimize with our optimization program. So as you know, the focus of this webinar is to look at Rhino integration. So before I dive in and start showing you Rhino and Grasshopper, let's just have a quick overview of what TAS is like to use and what a typical workflow might look like, in case you're not familiar. So generally speaking, you'd start in a 3D modeler. This is where you draw your geometry, and you can also do daylight calculations here and do shading calculations, and then you'd send that geometry to the building simulator. Then once you're in the building simulator, you'd add internal gains and construction information, you'd specify a weather file, and then you'd simulate that file to produce a results viewer file. The results viewer file has the temperature information for all the zones and surfaces, as well as load information, and you can look at airflow for natural ventilation studies, pollutant, things like that. And then from there, you can, if you want to, go onto the HVAC modeling program to model your HVAC system in quite a lot of detail. Or alternatively, you can go into Ambience 3D, which Ian's going to show you later. So you can look at the airflow in more detail in the space. Now, you can add geometry to the 3D modeler from external sources. Usually we do that via GBXML or IDF, although there are a few other formats that we can import too. But GBXML and IDF are the relevant ones for this talk. So we can also import.
Sorry, Andrew, just in terms of Rhino, we're talking via Honeybee, is that correct?
Yeah, exactly. So I'll show that on the next slide, but there are alternatives that you can use to get geometry into those formats ready for us. But shade surfaces, yeah, we can import those using 3D DWGs, and that's useful for shade buildings, but it's also useful for if you're trying to model detailed external shades adjacent to a window. And then again, we have the API for bidirectional data flow. So each of these core applications has the API, and that's useful not only for getting data into TAS, but also if you want to display those results that you've got from TAS back into Rhino or into another package. So I'll show you that a bit later too. And then once you've got everything in TAS, you can go off and do all these various types of analysis. I mean, there's quite a lot of them, from overheating to energy, TN54 neighbors, daylight calculations, or optimization programs and regulations. So, and there's probably quite a lot more that we haven't got on this diagram because, you know, the software has been around for quite a long time now. So there's quite a lot that you can do with it.
It's also worth pointing out, sorry, Andrew, to butt in quickly. It's also worth pointing out that a lot of this development has come from the fact that we not only develop the software ourselves, but we use it for consultancy in-house. So quite often, a lot of the development work is driven by projects that have come through the door and we've had to perform. Yeah. Sorry, Andrew.
Exactly. No, that's all right. So I'm going to be using Honeybee in this demo just to get the GBXML file that we can import into TAS. And I'll also show you IDF as well, but I'll start with the GBXML. But I think there's other tools that you can use, such as Pollination. I think they produce an IDF file as well. That should be able to go into TAS, no problem. So Honeybee, I'm sure most of you are familiar with it, but it's a Grasshopper plugin, and it's part of Ladybug Tools. And under the hood, it uses OpenStudio to do energy analysis and generate GBXML and IDF files, and also import them. And you might be wondering, you know, why bother using TAS if you've got energy analysis as part of OpenStudio? I would say the main reasons would be the speed, because TAS is quite quick to simulate, and also it's fully accredited, so you get access to the latest building regulations. You get access to the RCFD package, which is definitely unique. And again, the API makes it quite a lot easier to work with. And of course, if you have a TAS license, you get full software support. So because we developed our own engine, if there's a problem or a question you have about the software, you can just contact us and get a quick response. So that's quite valuable, I think. So I'll just jump into Rhino quickly to show you my setup. If I can find it. Got quite a few programs open here.
Yeah, generally in meetings, Andrew's taskbar is quite terrifying.
Yeah, sorry about that. So yeah, I'm just going to show you a very simple geometry initially, but obviously this will apply to much bigger buildings of any size, really. I'll just start with something simple so you can see the concepts involved. So I've just made 3 boxes here, 3 cubes, cuboid, and this is my Grasshopper script. So all I've done is I've created a room solid here, Honeybee room solid, where I've connected up these geometries. And then I've solved the intersections. And the reason I've done that is so that we get matching faces between the zones, and that way we get heat transfer between the zones. They don't come across as adiabatic. And then I solve the adjacency for that, yes. And then I add apertures by ratio. So I add some windows to the building, and then I pass that to the model object so I can create the Honeybee model. And then from there, we have the two different pathways we can take. We can create a GBXML file using the dump GBXML component, or we can use the model.osn component, which can produce an IDF file. So if I turn this on and hide,
IDF's preferable because that's also got the construction and internal condition stuff in it. Is that right?
Yeah, exactly. So even though GBXML can specify construction information and internal conditions, if you use the IDF route, then that comes automatically into TAS. But the two, from a geometry point of view, the two are very similar. But yeah, the IDF is advantageous if you want that extra information to come across. So as you can see here, this is quite a simple model. And I will generate the GBXML file by toggling this on. And then I'll show you how that comes into TAS. So I think I have TAS 3D open. There we go. So once you've got TAS 3D open, our 3D modeling program, you just go to import and press GBXML and select the GBXML file. And then you're presented with two windows here. So you can see a preview of the geometry that's going to be imported, and you can see this import report. And the import report is quite useful because it tells you any issues that TAS 3D has detected whilst it was doing the import. So for example, you might have surfaces which have the wrong orientation, or you might have small gaps in the model, and TAS 3D will try and automatically fix those things. And if it does need to fix anything, it will tell you what it's done, so you're aware of the issues in case you need to go and fix them in the source geometry, or in case it makes an assumption that isn't right. But generally, from Honeybee GBXML files, I haven't really seen any issues with those at all that I can think of. You do sometimes see issues with Revit GBXML files, but it's been very good with Honeybee so far. And then you also have this dialog here. So this shows you the zones that are going to be imported. But if you go to the display tab, then you can inspect the geometry in a bit more detail to see what's going to come in. So for example, if I unselect ceilings and roofs, then you can see I've got the walls selected here. I can turn the floors on and off, and that's quite useful because again, you can quite easily see if something's not quite right. One of the surfaces got one of the wrong types. And if I change to color by analysis, then we can also see the boundary conditions and the types of surface that we've got. So for example, here, I can see the green one's exposed, so they've got the external boundary condition. But then we've also got this pink color here, which is the link color, to show that there is actually heat transfer between these spaces. So that's quite useful. So I'll press OK to import that. Even on very large files, the import's very quick. It's almost instantaneous. Yeah, so here's our geometry. And then if I want to, I can press this button here to create plans for editing. And this is quite useful because you can do things like you can alter the zoning. So for example, if I wanted to split this space, I could use a null wall, which is in some packages is known as an air wall, and I could subdivide this space. And then I could change the zoning if I wanted to. I could make a new analysis zone and split this into two zones, for example, and that can be quite useful. The other thing I can do as well, if I take the imported windows, for example, I could edit these imported windows. I could say give them a frame percentage of 10%, and therefore when you get into the building simulator, you can assign a different construction to the frame pane, so you get more accurate building simulation results. So if I leave this open and I go back to Rhino, and I change, let me turn this GBXML toggle off. If I change the size of the windows, say, let's make them narrow. There we go, narrower windows. And then I update my GBXML file. I go back into TAS 3D. Then if I click import GBXML again and select the new GBXML file, TAS 3D will ask me if I want to update the existing building geometry. And what it will do in this case is it will try and remember the changes that I made to the model and reapply them. So as you can see here, it's remembered that I added that 10% frame. So I know ideally you should be doing all these things in the source package, but if for some reason you do need to make a change in TAS 3D, we do try and make your life easier so you don't have to keep repeating work. So that can be quite useful. So now I'll show you, I'll just make a new file here. Now we'll take the other pathway, so I'll turn that one off, and I'll generate the IDF file. So that's just been generated there. Copy that and go back into TAS 3D, and we've got someone in the lobby. Insert them in. So if I click import IDF instead, Then I can select my source IDF file. I can give it a name. I guess I'll keep it at the current name, and I'll put it in this folder. And then I can tick this box to have a building simulator file created too from the information that's in the IDF file. And I can say what I want it to bring in. So I'm going to say bring in the internal conditions, model the internal mass, model. I'm going to import the unused constructions as well because it's useful for visualization purposes. And then I'm going to select an EPW file. I think I have one in my downloads folder. I'll press import. This is the bit where I find I'd left the TBT open and it's not going to work. Oh, there we go. So again, this looks very similar to what we had before from the GBXML import, but here's the colors are just slightly different. But again, it's pretty much exactly the same. But interestingly now, if we look in the output folder, we have a building simulator file which has been created. So in here, we can see that it's created a file with weather. We've also got the building elements that have come through. We've got a list of rooms, and we've got our internal conditions, which have heating and cooling set points. We have our constructions. So one thing that I'd like to draw your attention to while we're in here is the visualization, because this is a really useful tool. Oops, what have I done? There we go. So if I open the visualization here, this is really powerful because you can select things in the building simulator and see where they are in the model. So for example, I know this single pane construction hasn't been used anywhere. So if I click on that, nothing gets highlighted. But if I click on the double pane here, which I know has been used, then those surfaces get highlighted. And that's very useful because if you end up importing something and one of the constructions has been applied to the wrong surface, the wrong building element type, or one of the surface types has come in incorrectly. If, for example, I click on interior wall and I see one of these outer edges highlighted, then I know right away that there's a problem and that one of my interior walls has come in as a external wall. Something's not quite right down. Then you can go and fix it. So that's extremely useful for model checking. So I'll simulate this now, because again, this is ready to go. Should be very quick. And this is our results viewer file. So in here, I'll have a look at the performance summary just to pick a day which is quite interesting to look at. So I can see the maximum air temperature happens on day 189, hour 13. But if I click on that and I click on load breakdown, I can see what is contributing to the zone temperature balance for that day. So here I can see, of course, the solar gain is quite significant because I've got those big windows. So they're a major source of heat. I can also see that we're losing heat through conduction through the windows as well to the outside, and I can see the effect of heat moving. This one shows you the effect of heat moving into adjacent spaces and into the fabric, and I can see equipment gains and things like that. And if I go to the visualization here, you can see all that information visualized. So, I could step through the hours and see how the dry bulb temperature of the zone changes. You can see the wind direction and magnitude, and you can pick from all these different variables. So, I said earlier that it has cooling set points specified. So if I click on cooling load and step through, I might have picked a day which is unoccupied. Yeah, I did. What day 190 there, we can see the cooling load reflected in the colors. And you can also view surface temperature results here as well. So if I click on one of these filters here, you can see all of the different types of results that you can see just in this results viewer, both visually and in a tabular form or graphical form. So there's lots of information here, and all that's accessible via the API as well, which is quite useful. So yeah, from here you can go and do building regulations, generate various reports, things like that. Sorry, you
we actually. Yeah, I was just about to say we actually use these APIs ourselves internally, don't we, for the macros that do all of the sort of regulatory calcs,
exactly.
et cetera. Yeah,
exactly. So let's leave TSD for now and go back to Rhino. So one thing I would like to show you as well is, one of the reasons that you might be using Rhino is because it's very good for parametric design. I'm going to turn this off here. And I've got the exact same script that I showed you just now. This is the exact same Grasshopper script, but instead of going from model to IDF, just from model to IDF, I've added some extra components. So if I turn, let me just make sure everything's set correctly. If I turn this on, again, it's the same model, but instead of just producing an IDF and leaving it at that, I've got these extra components here. So I've got one here which takes the IDF file that was produced by the OSN component and imports it into TAS, and then that will generate the T3D and TBD for us automatically. And then I've got this component here, which takes the TBD that was generated from the previous component and actually simulates it. And then from there, I have another component which extracts the annual cooling result. And then I have another component which manipulates those results into the format that can be displayed by color rooms. So I'll just turn that on.
So, sorry, just to be clear, Andrew, I'm not an expert or even a beginner where Rhino is concerned, but each of those components are effectively using our API to get the work done. So it's
yeah, exactly.
Okay,
exactly.
So it's like a scripting environment.
Yeah, exactly. So I'll show you what the code looks like for that in just a second. So I'll just run this one now, and it will create those files for us. Sometimes it can take a couple of seconds to run. Yeah, it's a shame that this version of Grasshopper is not multi-threaded, but this is finished running now. So I'm just going to lock the canvas, lock the solver. So if we look in our Rhino model, I turn off let me turn off that visualization temporarily. Then we can see the cooling result has been drawn back into Rhino for us, which is quite nice. So you can see, obviously these zones with the windows have the highest cooling demand. And what you can do as well is you can, if, for example, I take this color rooms. So color rooms is actually one of the Honeybee Energy visualization components. So what I've done is I've just written something that links the two together.
Okay, so just sorry again. Sorry, Andrew, I got to keep asking the questions. So this is basically just removing the building simulation part of the Honeybee process and replacing that with TAS ultimately. Okay, good.
Exactly, because if you're doing parametric design, then what you usually want to do is you want to tweak your design and then see the effect quite quickly without having to go through too many hoops. So what I'm going to do now is I'm just going to bake this geometry quickly. There's probably a better way of doing this, but I'm just going to bake this quickly, and then I'm going to move it over there. There we go. And then I can turn that pathway off and turn the visualization back on and unlock the solver. And then I can change something. So say, for example, we change the openable area of the windows. We make the windows much bigger. And then if I run this again, what it will do is it will again do the same thing. It's changed the window, so it will re-import the IDF file. It will recreate the building simulator file. It will re-simulate, and then it will extract the results. It will create that header so that the Honeybee color by rooms object understands how to present the data, and then we should see it appear back here in the plan. So I think that's finished. And if I turn off preview, lock the solver so I don't slow it down by accident. So yeah, here we can see the result with the much larger windows. So you can see the cooling demand is bigger. So that again, so this is just one thing that's possible. There's quite a lot that you can do with the API. If I jump back to my PowerPoint presentation, then yeah, like I said, the API is very powerful and flexible because it's been in the UI, been in the software since the beginning. And it mirrors the UI actions, which makes it quite intuitive to use. And using it, you can create things like Grasshopper plugins. We've had customers create Rhino plugins, Excel macros. I've made AutoCAD plugins, and you can have completely standalone utility applications. And as Ian said earlier, we use our API extremely extensively. Quite a lot of our applications that we ship with our software uses our API. I mean, that's how our 3D modeler actually puts geometry into the building simulator. So it's very well tested, and we understand it very well. We can support it, and there's not a lot that you can't do in it, that you can do in the UI. So just to show you what the code might look like, and just to emphasize this point that it mirrors the UI actions, I'll show you what the source code of this TAS simulate TBD component looks like that I used as part of that demo just now. So if you imagine how you would open a TBD and simulate it, what you do is you'd open the building simulator, you'd open your TAS TBD file, and then you just press simulate. That's what you'd have to do. So if we look at the code, this is what the code looks like. So line 90 here, we just open the TBD file, essentially. 91, we open our specific document. And line 98, we simulate. And then on line 105, I just add a comment here so we can see what the result of our simulation is and just check that everything worked okay. So, it is actually quite intuitive, and, we do support our API as well. So if you wanted to have a go at making a component, or if you wanted any of the components that I've demonstrated today, just get in touch and I'll send them across. And then before I pass over to Ian, again, what I'll do is I'll just show you the geometry that Ian's going to demo in the CFD application, because I did actually make it for him earlier.
I'm glad you're going there, Andrew, because I was thinking my dome doesn't look anything like that rectangular office.
Yeah, so I made this quite a simple dome here. Let me turn off the Honeybee geometry temporarily. So that's the dome I've made. Let me turn this off. Oops. There you go. Turn that on. So yeah, I made this quite a simple dome hemisphere here, and then yeah. So what I've done is I've made the simple hemisphere, and then this yellow area here, this is going to be transparent. This is going to be double glazing, and then the top here is going to be opaque.